talk about bridges next. That's the second part of this. We're not quite halfway, but we're getting there. Okay, so that's a bridge. Any questions? So a bridge is basically like a transport layer between two independent consensus protocols. So you can think about like Bitcoin and Ethereum, or you could think about Dogecoin and Polkadot, or something like that. Two totally independent consensus systems that have like different validator sets, or different proof of works that they're orthogonal to each other. And so while they don't rely on each other in any way for consensus information, it might be useful to be able to like move an asset from one chain to another, or like prove that you own an NFT on this chain in order to unlock a capability in some game on this chain, or any number of things you might dream up. And they're named the source chain and the target chain. Okay, so the target chain gets to learn information about the source chain through the bridge. So that would mean like maybe you can send money from the source chain to the target chain, or prove that you own an NFT on the source chain and use it in a game on the target chain, or something like that. Okay, so when you want to talk about a two-way bridge, most of the time in reality we typically think about two-way bridges. Like I can send my coin from Bitcoin to Ethereum, but then later maybe I want to send it back to the original Bitcoin chain. So what's really happening there, at least the way we conceive of it, is that it's two different one-way bridges. You can almost think about it like a highway bridge, where there's like one lane going this way and another lane going back the other way. Okay, so here's the problem. Source chain reorgs. Imagine that this is the source chain up top. I should have had arrows here, but whatever. So here we've got like Genesis is somewhere back here, and our chain progresses to the right. And at some point, we relay some information from this block over the bridge into the target chain. And the target chain maybe takes some like side effects, lets us use that thing in a game, or lets us like trade our bridged asset on a DEX, or any number of things. And then the source chain reorgs. It's basically like we could execute a double spend, but the victim isn't someone selling us their motorcycle. It's something happening on chain in a different chain, in a totally orthogonal consensus protocol. So this is the like main problem in bridge design that we need to solve for. We want to be sure that like before the target chain acts on any information it hears from this block, that we're never going to reorg away from this block. So do any concepts come to mind that might help us with this? Yeah, I heard someone say it, finality. Yeah, at a high level, we want to make sure that this block is finalized. So we're going to dig in, because don't worry, there's a lot of tricks that might happen. So there's two bridge models. There's the trusted bridge. The classic example is the WBTC Foundation. That's the wrapped BTC Foundation. And it's basically a group of people who got together and said, hey, there's value in letting people move their Bitcoin tokens over to the Ethereum network. And the way it works is that the WBTC Foundation has a Bitcoin wallet, and you send your Bitcoin to those people who work at the foundation, and once they're convinced that they really own those Bitcoin, then they mint you a token on the Ethereum network, on the target chain. It's called WBTC, or wrapped BTC. And it's, for those of you who know about like ERC20s, it's an ERC20. It's just some token. You can like do whatever you can do with any other kind of token. And then maybe at a later date, you use the other lane of the bridge, and you send your WBTC back to the same folks who work at the WBTC Foundation. And once they're convinced that they actually have that money, then they send the original Bitcoin out of their wallet back to your wallet, or wherever you tell them to send it. So what's the problem with that? Yeah. The trust, right? Like everybody probably knows it already. Like I described the protocol as like you give them the Bitcoin, they give you the wrapped Bitcoin. But the other thing that could happen is you give them the Bitcoin and they say, get the hell out of here, I never got your Bitcoin. And then that's the end of the story. Now in practice, the WBTC Foundation seems to be doing a great job. I don't know of them scamming anybody, but that doesn't mean they won't scam you tomorrow. Or maybe they're not even malicious, maybe they just accidentally lose control of their keys and they're the ones that get scammed, and therefore you get scammed on as a downstream side effect. So something interesting that I want to observe about doing this with Bitcoin is that you guys said and observed like finality is going to be really useful here, but Bitcoin only has probabilistic finality. So the WBTC Foundation has to make a judgment call, just like everyone else who ever receives a Bitcoin has to make a judgment call. They have to say, when am I confident enough that I really have this Bitcoin before I send the tokens over? Okay, so that makes building any kind of bridge from probabilistic finality like a little bit hard and a little bit dangerous. We're going to try to do a little bit better once we have provable finality with like Grandpa or Tendermint or any other Honey Badger BFT, one of these BFT-style provable consensus protocols that we talked about. Okay, right. So the next kind of bridge is the trustless bridge, and obviously that's the kind that we like want to build. That sounds a lot better, sounds a lot more in line with the ethos of the ecosystem. So let's dig into how those designs work. Let me make sure I didn't miss anything. Oh yeah, just the point that like if you're working with a trusted bridge, it doesn't have to be quite as naive as what I just described. It might be built around like a multi-sig or something where like 5 out of 7 people have to be compromised before you get totally scammed. But like that doesn't really fundamentally solve the problem. It just kind of makes it a little better. Okay, so the most trustless way to interact with the blockchain is to run a node. We talked about that already. It's true for individuals, and it's also true for other blockchains. So if you look back to the figure of the bridge here, you can almost think of the target chain as being a user of the source chain. In the same way that a human might be a user of the source chain, the bridge is relying on getting some information from the source chain, and we want it to be able to do that in the most trustless way possible, and that's not by trusting the foundation to always tell you the truth. We just learned a technique to interact with a blockchain relatively trust-free, and it worked well in a low resource environment. And it turns out that running on a blockchain is an extremely resource constrained environment, just like your Raspberry Pi and just like your microcontroller. So the secret or the key observation to building a trustless bridge is that a trustless bridge is actually just a source chain light client running on the target chain. So in the same way that I said, you can use a blockchain relatively trust-free from a light device like your phone by running a light client on it, the exact same thing is true for a target chain. If your target chain wants to interact trust-free with the source chain, it should run a light client for that source chain. And so putting the light client as on-chain logic is sort of like the key fundamental observation in building a trustless bridge. There's a lot that can go wrong after that, but I'll just like let that sink in for a second. You run a client for the source chain on the target chain.